Hello, SIT232. This is Lily speaking, and today I will be showing you how to do the 5.3D task, which was all about the finite state machines and, as a bit of an advanced thing, also using states instead of, and classes instead of switch cases. Now I will walk you through it, kind of explain, especially in terms of the example of the light machine, where the light starts off. When you press it, it'll turn on and set a timer for 5 minutes. When that timer is over, it'll go to dim mode, where it'll go to 70% brightness, set a new timer, and then when that timer is done, it'll finally turn off. And then obviously whenever you press the button again, it'll go back to being turned on and reset the timer. Okay, so I kind of already made a lot of this myself. Just to kind of give you guys, just to visually show this. So obviously we begin, we need a controller, a GUI, and a light class. For the light, I chose not to use a interface. That's not important right now, but it just made it easier on me to ensure that I can implement things properly. Now, so we started the GUI, it's very similar to what was given in the task. However, instead of a regular set display, I set it to int%on because I changed the actual GUI. So it depends on the percentage light there is. So it'll display divided by 10 because we don't want 100 characters, but it's basically just a little it'll basically just show this, and then like, let's say 1 2 3 4 5 6 7 8 9 10. If it's on, then it'll show this. If it's on 70%, and then it'll just show 10 spaces when it's off. It's very simple, but that's just how it works. Default is obviously 0, so it'll do that. With the controller, again, very similar. You just connect the light and GUI instead of what it was in the thing, and you only have one button press event. So you only need to worry about that. The machine, basically identical. Like, you've got the on-timed event, the timer, but this time we're doing it in seconds as specified in the machine. So I am assuming you've already read this document. It's included in the resources for the task. But yeah, so that's kind of specified already. The timer will be counting in seconds. So then we initialize everything, and then just the simple UI loop. We check for enter or escape, and if it's enter, we click button pressed. Otherwise, if nothing happens, just the tick event. Now, if we go to the light controller, again, very similar. Now, you'll see that some of these things are not implemented. I have gone ahead and actually properly implemented all the states and stuff, but I want to kind of walk you through that a bit more. So I think that'll be the more important focus of this. So basically, we have all of the current states. So you'll notice it says dynamic here, and you might be thinking, well, it doesn't have a type, and that's the point of dynamic dispatch. It doesn't have a type because it'll be dependent on the type of state. So if we have different states, so we'll let's start by creating ourselves a new class called state. Oops, hold on, give me a second. Gotta get rid of that. Create ourselves a new class called state. And now we want this to be a an abstract class. Because we will be working on this. So, what do we want our state to have? Okay, so first of all, let's start from the very start. So we need a tick event, so something that happens every time the tick happens, so every 1 second in this case. And the next thing we want is that we want to be handling the state changes within our own states. So I will be calling that, so we've got public abstract int tick event. Now the reason I'm using an integer is actually quite important. I've actually run into this problem before on my own task, and it's so that so that you can pass this int back into the controller, so that it will know whether to, like, if you look at this, you'll see that on the tick event, it'll say int next. So it's storing the return of the tick event. And if next equals 1, then that means that we want to go to the next state. So I'll call next state on the object. Now, the reason that is important is because we want to abstract and we want to decouple the states from the controller. So that the states are basically controlling themselves. They're not controlling themselves, but they are moving forward on themselves. Like if you look at this diagram that's given, within the state, it is doing something, and then it is passing on this parameter. Like when press happens, it will then move on to the on state. So we want an integer to make sure that if something, if our, like for example, if tick and timer equals 0 happens, so if timer goes down to 0 while in this tick event, we want our controller to know that we need to move to the next state. So next thing, public abstract state next state, and then we'll use a char ch to know whether it happened because we the button was pressed, or whether the tick event happened, because we can have different, as you can see here, we can have different results from that. So if we get it from a button event while we're in this on state, it should be returning a new on state with the timer. And if it's the timer event, then we want it to go to dim. And now we'll also include light, so that we can then also set the light. Now something else that we want is we want a private static int called the internal timer. So this needs to be universal across all of the states, all of the different subclasses. And the reason for that is so that it will never be mixed up. It will never be created again. We want it to stay universal so that we can always access it from within our states, no matter what. and now you'll see that I'm using a reference by reference, and that's just kind of a bit of a failsafe just to make sure that no new instances are created. It's not that important, but it's just to make sure that it's all very nice and just yeah. Now the next thing we do, and I think we can make this internal actually. Next thing we do, so we'll just go through each state and implement them. So we'll start at off, and actually, the best way to do this actually is to just make out a skeleton for each of these states. And once you have all of them kind of declared, then kind of go into the implementation, and you'll see why in just a moment. So we've got internal class, got state off, taking from state. So the first thing we want is actually the constructor, so that we can set the light accordingly. When it's off, obviously, what we can turn the internal time to 0, set the light dot brightness to 0, and that's all that needs to happen within the constructor. That's all. That is all it's doing. If you look at here, it's just the light 0, and I'll be using the constructor to do all of this because it's just something that needs to happen once it's being created. Next thing, public override tick event, and then public override state next state, and we can just pop in temporary not implemented exceptions. Then because then we've got state on is the order that I did it, because that's kind of the chronological order that you'll go in. So it just makes it a bit easier for me personally. Now when state on is created, we want to turn the internal timer to 5 minutes, which would be 300 seconds, and turn the light brightness to 100. Let's activate, set up the tick event, then next state, and then finally state idle. Sorry, dim. Inheriting from state. Now, when dim happens, we want to set a timer for 2 minutes, which is 120 seconds. And set the brightness to 70%. Then tick event. Then this. All right. So now we've got all this framework. Now let's start actually implementing state off. So we'll start with the tick event. We can just in timer ++ and then return 0. Nothing will ever happen by just ticks in state. As you can see, whenever tick happens, it'll just return. Next state. Now here, the way I do this is I ensure that, first of all, no, sorry, actually, with this one specifically, with state off, it doesn't matter where the tick event comes from. Like, sure, you could potentially, something you could do is add in some error handling to make sure that that this will never be called, if this will never like actually occur if it's a tick event, because you never want that to happen. Like whenever a tick happens, you want it to just stay here. You don't want it to go into next state. But that's kind of already handled with this return 0, so it doesn't really matter that much. So we can just create a new state. Let's just call it on, new state on, and remember to pass in light and return on. And if we go back here, and that's the reason that I wanted to create them before implementing everything, is because I'd need to refer to this to state on. And then, as you see here, the current state is assigned to that return value. Now let's go back to our state on. Now with the tick event here, we want to decrement the timer. And this time, instead of just doing nothing, we need to check if the in timer is equal to 0. And if it is, we want to return 1. Otherwise, we'll just return 0. The 1, if we go back to light controller, on the tick, if next equals 1, we call this dot current state, next state, with t for tick. And so if we go back to state, we change this. So we need to check where this is coming from. So if it's, if the given character is a t for tick, we want to create, and if we follow this, if it's a tick, then we want it to go back to dim. So we want it to go to dim, sorry. State dim equals new state dim light, then return dim. Otherwise, we don't need an else statement because of the return. Otherwise, we just, we know that otherwise it's always going to be a B for button press or button event. So it's going to do this. So it's going to create state on equals new state on, return on. And the reason we create a new one, even though we're still in here, is so that we can call this constructor. Just to make it a bit easier on ourselves. Because that way we also don't need to do anything here. We don't need to do any kind of extra stuff. We can just handle that all within the states. Okay, now we go to dim. So, again, we decrement the timer, and we check if timer is 0, we return 1, else return 0. Now we need to check if the character given is a tick event. We need to create a new state called off and return off, because if it's a tick event, if you see here, and the timer is 0, which will be called on next state, then we just go back to off. Otherwise, if press called, we need to go back to on. And now, if we run this, should work. Just give it a second. Ooh, what happened? State off doesn't seem to exist. Is that? Yes, okay, sorry. That'll be because these are using the wrong namespace. So if we go back because I called this something else in my testing. Light switch. Some light switch. Interesting. Actually, how about we just change this to be light switch FSM. Interesting. Oh, right. Of course. I forgot it had to be underscores. Now should work now. So we see if I zoom in here, if I press enter, turns on. Now what you'll notice here is that this is going to take 5 minutes. So something that we can do to just make our lives a bit easier, we can go back into the machine. Just for testing purposes, we can change it to 10 or even 20. So that every 20 milliseconds instead of 1 second. So it'll take, I believe that's just a problem with the, oh, that's strange. I believe that's just a problem with either my computer or Visual Studio. Let's run it in debug mode. Interesting. Let's see why that's happening. Let's go into light. No, sorry, let's go into the GUI and check why this is being called so fast. Let's put this back like this, bring this up. Let's see what's happening here. Right, yep, that's all good. If we continue. Interesting. There seems to be a problem with how tick is being called here. So let's check this out. Let's go into Light Machine. Actually, let's go into State. Because I believe it's happening because light is being changed every second. Although, that's weird. It shouldn't be. Hold on. Tick. If we go to the controller, let's look at the tick. Ah, yes, this will be the culprit. Let's... Right, okay, I understand. Let's put this here. And also here. So that it'll only happen when a tick event happens. Now this should work fine. Now if we press enter, it goes to full. Should be about 6 seconds, I believe. There we go. Now it goes to 7%. I think 4 seconds. It goes to... And there we go. There you have it. Now, if you have any questions, feel free to email me at S2233 at deakin.edu.au. That's there. If you have any questions, comments, or any follow-ups, really, I'll be more than happy to try my best to help them, answer your questions. Now, have a great day, and I wish you all luck.